Hello again, ladies and gentlemen. Mr. Donnie here. Going to go over some chemistry. We're going to look at pressure, boiling points, and vapor pressure. So the objective of this video is to hopefully get you guys to be able to explain what the above terms are and how they relate to each other: pressure, boiling points, and vapor pressure. Use table H in the reference tables to determine boiling points, and answer an interesting question: why do my brownies have special cooking instructions for high altitude? It's like if you're above this elevation, then cook this way. It's weird. Why? All right, so first question is, well, what is pressure? Pressure is defined as a force exerted on an area. So a common unit for pressure would be PSI, or pounds per square inch. So let's say I had 1 square inch and I put 1 pound of pressure on it, or 1 pound of force on it. What would the PSI be? It would be 1 PSI, right? If I put 10 pounds of force onto, let's say, 2 square inches, what would my pressure be? Well, it'd be pounds, 10 pounds per square inch. So you get 5 psi. All right, so other units that we're going to use more often in chemistry is going to be 1 atmosphere. And the way that we came up with that pressure is basically, you got the earth and you got all the air above it, right? You have the atmosphere surrounding it. Well, that air has mass, so it exerts a force down onto the earth, and it has a pressure. We call that pressure 1 atmosphere because you have 1 atmosphere of air pushing down on it. That's equal to 14.7 psi. So right now, you sitting there have about almost 15 pounds of pressure from air per square inch pushing down on you. You don't even realize it. And the other unit that we're going to use is kPa, or kilopascal. And here's the conversion for it. 1 atmosphere is 14.7 psi, and it's also 101.3 kPa. All units you can find on your reference tables. So what is pressure? Or what causes pressure? Right. So here I've illustrated some gas particles as the red spheres and arrows to show where they're going. So the pressure is basically from the molecules and atoms colliding with the wall. So they're hitting it with some force, and that's causing a pressure. So all these atoms are stuck in there. They're going to hit the wall with some force and bounce off, and that's going to cause the pressure. That's literally what the pressure is. Right, which brings us to the next term, vapor pressure. And if you were to venture a guess, what do you think is causing the pressure? Vapor, which is just a gas. So if we had some liquid in a sealed container, down here drawn in red, it's in a sealed container, some of that liquid is going to evaporate and become vapor. Now those vapor molecules in the vapor phase, are going to collide with the sides of the wall and cause a pressure. So vapor pressure is just the pressure caused by the vapor, the part of the liquid that evaporated. Now boiling points are pretty cool. So boiling points happen when vapor pressure is equal to the same as the external pressure. So here we have a certain amount of pressure from those particles becoming vapor, and we also have the external pressure. The way I think of it is kind of like a push and shove match, right? We have particles that are trying to become vapor, and we have the external force, which is kind of pushing them back in, right? At one point, once they equal each other, once the vapor pressure is equal to the external pressure, all of those particles are going to want to turn into a gas at once. They've now turned the odds against the environment, and they can all go into the gas phase. So boiling is really just everything trying to evaporate at the same time. Now we have a special term called normal boiling point. Now you may ask, well, what's so normal about it? And it has to do with the pressure. So normal pressure we consider to be 1 atmosphere. So the normal boiling point is the temperature where the vapor pressure is equal to that. It's equal to 1 atmosphere. So we have a chart to figure out what normal boiling points would be. I'll skip that for now. So if we take a look at the reference tables, 1 atmosphere is 101.3 kPa. So here we have a dotted line that is showing us normal pressure. So here are 4 different substances: propanone, ethanol, water, and ethanoic acid, and their vapor pressures at different temperatures. Right? So vapor pressures on the Y, temperatures on the X. So the question would be, all right, well, what's the normal boiling point of propanone? Well, you would follow the normal pressure, 1 atmosphere or 101.3 kPa, until you hit that line, and then you'd follow it down. You go, all right, well, how much is that? All right, now be careful with the scale. It goes 50 to 75 and it takes 1, 2, 3, 4, 5 boxes. So we know each box is worth 5. So that right there, normal boiling point would be about 55 degrees Celsius. Followed across for ethanol, you go down, hits the line about here. That'd be about 80 degrees Celsius. Water, about 100 degrees Celsius. And ethanoic acid, it's going to be right in between there. So we got 105, 110, 115. So I would say probably like 117 degrees Celsius. So what's cool about knowing this relationship is you can use it to your advantage. For example, pressure cookers, right? Basically, it's just a big pot that seals and locks on and doesn't let any gas out. So whatever you put inside is trapped in there. Nothing can escape. So what happens as you heat it up? You heat it up. Well, some of the stuff goes into the gas phase and becomes a vapor, and the pressure increases. Now, as the pressure goes up, what happens to the boiling point? The boiling point goes up. All right, so it's not going to boil because the pressure is going higher. What you're doing is making the boiling point be a lot higher than it normally would. So what happens is this stuff can get a lot hotter because it's not going to boil until it gets to a higher temperature. Normally, if you had a pot of water on the stove at 1 atmosphere, it's going to boil at 100 degrees Celsius. But if you were to put it in a pressure cooker and start boiling, well, the pressure is going to go up, so the boiling point is going to be higher, and now you can get much hotter water, which means you can cook it faster because it gets hotter. Pretty neat. So here's some practice examples. We already kind of did some of these, right? Propanone, we said, was about 55 degrees Celsius. Ethanol was about 80 degrees Celsius. H2O was 100 degrees Celsius. And I think ethanoic acid, we said, was like 117 degrees Celsius. So here's some other problems. What would be the boiling point of water at a pressure of 200 kPa? All right, so first off, they tell us 200 kPa, so let's find that. 200 kPa right up here. Well, if that was our pressure, what is the boiling point going to be of water? So we want to find the line for water over here. So basically all you do is you follow that line over for 200 till you hit water, found it, and then you follow that down to the temperature, and you get about 105, 110, 115, or get about 117. You're about 117 degrees Celsius. Well, what would the vapor pressure be of propanone at 50 degrees Celsius? All right, so this is similar but different. Here they gave us the temperature, so we're going to use the temperature. We're going to find the 50, and they're talking about propanone, so we want to find this line. We go up till we hit that, and we follow it over, get about there. Let's figure out the scale here. We got 50 to 100. We got 1, 2, 3, 4, 5 boxes, so each is worth 10. So that's 70. That's about 82. 82, and what are my units? Kilopascals, kPa. Now the question is, which of the 4 liquids has the strongest attractive force? All right, well, I'm going to go back to my diagram here. So let's think about attractive forces. So the stronger the attractive forces between the molecules in the liquid phase, the more likely they want to stick together and the less likely that they want to become a gas. So as the attractive forces go up, the vapor pressure goes down, because the more they're attracted to each other, the more they want to stay in the liquid phase. So if I go back to my chart, I ask which of these 4 liquids has the strongest attractive force, it's going to be the one with the lowest vapor pressure. The one that wants to be a gas the least. So which one of these has the lowest vapor pressure at any given temperature? The ethanoic acid. All right, you pick any temperature, you see it's the bottom one right there. So it has the strongest attractive forces. All right, well, I hope you found that helpful and interesting, and I'll see you in class. Bring some questions.